First, I'd like to introduce today Marie-Nathalie Contou-Carrere. Marie is the interim executive director of the Rice University Carbon Hub and research advisor for the Industry Partners Office of Research. As a research advisor, Marie combines business experience and in-depth knowledge of Rice to map corporations' interests and needs to the Rice research portfolio and establish collaborative research programs. The Carbon Hub, a research initiative launched by Rice in 2019, aims to accelerate the energy transition to the reliable and sustainable generation of green energy through the responsible use of hydrocarbons as a feedstock for the ubiquitous carbon materials. I want to thank Marie for being here today. And sorry, I think I butchered your name. I practiced, I promise.
It's totally fine. Thank you. So can I go ahead? Just making sure. Okay, so I will share my screen. Please scream if you don't see my screen. Nicely though. Okay, and here, where is my application? No, I don't. Okay, as always, it worked a few minutes ago, so let me find this. Okay, here we are. All right. Okay, everybody can see my screen, thumbs up. Okay, cool, thank you. So good morning, thank you for the introduction, for this opportunity to present the Carbon Hub. So I am the interim executive director for the Carbon Hub, which is led by Professor Pasquali at Rice University. The Carbon Hub is building a zero emission world by advancing clean hydrogen and carbon materials that can slash CO2 emissions from industry and transport. So currently, the world is facing this dual energy challenge: how to meet the ever-increasing energy demand while limiting CO2 emissions to meet the targets set by the Paris Agreement. And this sustainability challenge is a little bit like a whack-a-mole problem. Here I am, I hit the problem on the head, I think I have a solution, but I may have created more problems because the issues are all interconnected. I'll give you a couple of examples. Hydrogen is looking like a very promising clean burning energy source. However, there are no natural sources of hydrogen. So there is a color expanding palette that denotes the different pathways to produce hydrogen, each of them with their pros and cons. So gray and blue hydrogen generate a waste stream of CO2, and there is no financial incentive to actually store the CO2. Green hydrogen is extremely energy intensive, and you recover only a very small fraction of the energy you have to put into the process. And turquoise hydrogen generates a waste stream of solid carbon. At the same time, the primary offenders for CO2 emissions are industry and transport, which represent 43% and 25% respectively of the global CO2 emissions. And the industrial sector is the hardest of all to abate, because making metals and cement requires a lot of energy from fossil fuels to reach the temperatures you need, and it includes chemical reactions that will make CO2 as a byproduct. When it comes to the transportation sector, one of the tactics is to improve the energy efficiency of the transportation fleet by maybe replacing metals with lighter materials such as aluminum and carbon fibers, and by electrifying the cars so they become smarter. But when you introduce aluminum and carbon fiber, you're actually introducing metals that have a very bad CO2 and energy footprint. And when you add more cables to electrify the car, you're actually increasing the weight. So maybe your energy efficiency is not going up as much. So is it a catch-22 solution? Can we do something? So the Carbon Hub is about going beyond turquoise hydrogen to what we call azure hydrogen. So like in turquoise hydrogen, take your hydrocarbons, split them into hydrogen and solid carbon. And the splitting process does not generate CO2 emissions because you don't introduce oxygen. And also the energy that you need for this splitting process could be renewable, and it's a small fraction of the energy you recover as hydrogen. But if you start from methane, for every ton of hydrogen you make, you get 3 tons of solid carbon. And you get even more solid carbon if you start from other hydrocarbons. So the novelty here is, let's focus on the solid carbon. Let's do something about it. Why? Because hydrogen is a commodity, but solid carbon is a specialty. So the question, specialty product. So the question now is, what do you do with the solid carbon? Well, let's be smart about it. Let's make the right form of carbon to eliminate those CO2 emissions that I was talking about from industry and transport. Obviously, to get there, you need to have the right process efficiency, the right cost, and the right policies in place. So where are we going to put this carbon? When you look at the current market for carbon materials, it's very small compared to what the potential supply could be for carbon materials. Because on one hand, you would get 5.5 gigatons a year of carbon. And if you start from methane, you would get 22 million tons of solid carbon for each quad of hydrogen that you make. And the demand for hydrogen is growing up, and it's about to explode if you look at a recent McKinsey report. However, on the other hand, the current market for carbon materials is at the most 15 million tons a year. So we're really very different scales in terms of tons. Why is it so small? Well, all these carbon materials, the ones that are out there right now, they lack structural integrity. So there is only so much you can do with them. They are still expensive, and they do have an energy footprint and a CO2 footprint that would still generate CO2 emissions. So where can we go then? So in this graph, I'm showing the production of several materials in the world. I'm trying to get to my little pointer. I don't know if you see, oh, no. So what you see is that, so this graph is taken from a book by Ashby in 2013 with data from 2007. So it's a little bit dated in terms of data, but it just has gone up. We have added 2 blue points on the left to represent oil and natural gas. And what we see is that all these materials that are used at this very large scale, they all have something in common. They have structural integrity. So then the question is, what can you be displacing? You could go after cement, concrete, asphalt, but they're very cheap. It's 5 cents per kilogram, and they use in static applications. Whereas if you look at the metals, they command much higher prices, 80 cents to $7 per kilogram, and they are used in transportation. And also, remember those CO2 emissions offenders that we talked about before? Well, they are here. Cement, steel, and primary metals are those primary offenders. So the right form of carbon could displace these emissions from industrial materials. And so how big is this problem for the material energy nexus? So in this graph, I'm showing the amount of energy you need to mine, process, and refine metals in the world for primary steel, aluminum, and copper. And what you see is that it represents 12% of the world energy. So we always talk about the water energy nexus, but when you look at the amount of energy you need in that nexus versus the amount of energy you need for the metals, you see that actually metals are creating a much bigger problem. When you look at the CO2 emissions, the metals represent almost 4 gigatons per year of CO2 emissions. The blue wedge represents the CO2 emissions associated with water. So again, metals have really bad CO2 footprint. So a couple of years ago, in his blog, Bill Gates has asked, if somebody tells you they have a solution for climate change, ask them, what is your plan for steel? So what we say is like, replace steel with carbon materials. So why can it happen now? 30 years ago, that was not possible. But in the last 2 decades, research and technological developments have unlocked pathways to new forms of solid carbon, such as carbon nanotube and graphene. And these solid forms of carbon, particularly carbon nanotubes, have properties and attributes that overlap with those of metals in terms of strength, thermoelectrical conductivity, stiffness, and flexibility also, if depending on the application you have in mind. And you can put them in usable shapes, such as fibers, tapes, cables. So now we have a range of solid carbon materials that can be used in a diverse range of applications, from wiring, panels, beams for cars and buildings, to soil amendment for farming. And each of these markets represent tens of millions of tons each year, which is what you need if you want to match the scale of the energy systems. And I just wanted to show, this is a little harder maybe, but this is already happening. The fiber I have in my hands is entirely made out of carbon coming from methane. I can bend it, I can stretch it, I'm pulling on it, and it has electrical conductivity, thermal conductivity. So these things are not just a dream in the lab, they are happening. So obviously, to accelerate increasing the process efficiency, taking the cost down, and creating these new supply chains, cross-sector collaborations are required. That's why in 2019, Rice University established the Carbon Hub to bring together academia, industry, and federal labs. And it was launched with a $10 million commitment by Shell and additional funding by Prysmian, which is a cable manufacturer, and Mitsubishi Corporation Americas. And we're about to announce 2 additional corporate partners very soon. We also established a very large research ecosystem with over 80 research organizations, 80 researchers, over 20 different research organizations across the world, in the United States, Spain, the UK, France, Italy, and we're expanding to South Korea. And last year, we awarded $1.3 million for sponsor research, and the anticipated budget for this year is over $2 million. So in order to enable this bold transformation in how we use hydrocarbons, the Carbon Hub is comprehensively articulating and integrating 4 key areas. So the Piazza is a community building arm where the scientific and engineering community can come together. The Scuola is education workforce development arm. The Foro is a policy development arm where we want to ensure that policy, technology, and society needs and perceptions, they all remain in sync. And the Bottega is a research arm. So the goals of the Carbon Hub that aims at advancing reliable, sustainable, and affordable clean energy while slashing the CO2 emissions from industry and transport are aligned with several of the Sustainable Development Goals by the United Nations, because it's about producing clean hydrogen without any CO2 emissions from hydrocarbons, displacing materials that have a very bad CO2 and energy footprint with carbon materials, so decarbonizing the manufacturing and construction sector in that process, and also improving the energy efficiency of transportation because we're introducing lighter weight carbon materials that have a better footprint. So I want to leave you with one of the projects that one of our collaborators is working on. We're funding some of the testing involved in this project by Mark Gurthrop at MIT. He's receiving significant funding from the Department of Energy to work on this. And the idea is to build a house entirely made out of carbon materials. So this is how we're creating this zero emission future. So will you join us in making this possible? Thank you.
Hi, Marie. Thank you so much for that. So when you say come join us, how can people be part of this effort?
So when we say join us, thank you for the question. So first of all, we're building this ecosystem for the supply chain. So where we want to partner with people along the whole potential supply chain, from the energy companies to the producers of semi-finished products to the end users of carbon materials. So if you work in that sector, that would be very interesting talking to you and see how we can work together, particularly companies that make those value-added solid carbon. Then, if you are a researcher, an academic researcher, we're always looking for more expertise. We want to make sure we have all the experts around the table. So please come talk to us. If you're a community member, you're curious to understand how this is going to work out, because typically the lexicon is let's get rid of carbon. No, let's get rid of CO2. So it's not an either or. We can work with hydrocarbons to make this zero emission future possible. We want to talk to you and explain to you why this is important.
Everyone, please remember, there's a Q&A there if anybody has questions, but I definitely have more. Why is now the right time for something like Carbon Hub?
So until a few years ago, it would have been crazy to think that hydrocarbons could be used as a feedstock for materials. They were used to make carbon black, but at a very small scale. So now we're saying, no, it can be the feedstock at these massive scales that are similar to the energy system scales. Well, we can do it now because hydrocarbons are not considered scarce anymore. You have all other forms of energy sources coming online. Then there is also this increased pressure from stakeholders, governments, society, financial institutions to really think as a systems approach. You have to take into account the life cycle emissions of all your products. It's becoming increasingly evident that we have to work together to solve these CO2 emissions problems. So the pressure is there. Finally, in terms of performance of these materials, until recently, these materials were like in labs, in startups only. But now we have very good performance. We do have to improve properties for some applications, but the properties we currently have are good enough to displace metals in a lot of applications. Like what I have in my hands, this is real. This, it's hard to see with the virtual background, but this is already happening. So because of all these reasons, it's the right time. But what we are missing is a coordination. How do we coordinate this whole effort to really accelerate the establishment and deployment of these sustainable pathways from hydrocarbons to clean burning hydrogen and solid carbon materials?
A question from the audience. What kind of short-term goals does the Carbon Hub have in the next 3 to 5 years?
So our first goal is to have a small-scale plant that would be 3,000 tons per year. That's the important first step, because currently carbon materials do improve the intrinsic properties of some key applications, such as in wearables, advanced energy storage, high-end consumer products such as appliances, and in aerospace. So there are markets where it can penetrate, and that's what we need to do. We need to build a small-scale plant, because once we have that, we can start learning how to improve the process efficiency and take the cost down. And we establish a reliable source for these carbon materials, and one that is economically sound. So that's the first step, and that will happen. We are working to make that happen. Yes.
Well, thank you, Marie. I think we'll move to the next talk. Again, thank you so much for being here.